All right, so here's part two, the next two problems. We're going to tackle these just like the previous two. And so we're going to have to find the missing side lengths. And then once we get the missing side lengths, we can add them together to find perimeter. And again, I'm going to keep emphasizing, because I don't want you guys to get confused on the test, these are like two separate things. So finding side lengths could be a question, finding perimeter could be a question. And so you don't always have to find the perimeter on these questions. All right, but first step, let's identify a reference angle. Okay, because as soon as we identify our reference angle, and we could have used a 42 degrees, that would be his complement, but we're choosing to use 38. Let's label some side lengths, and so we have the opposite side. We have the hypotenuse along the top, that's across from the right angle, and then we have the adjacent side touching the reference angle. Okay, so it looks like we have to find the hypotenuse and the adjacent. Well, I already have green selected, so let's solve the adjacent side. So we're going to, again, compare our reference triangle. To our actual triangle ratios. Okay, because we know if the triangles are similar, those ratios have to be the same. I want to find adjacent, and I was given opposite, so that means I have to use opposite. Ooh, that's not going to work. Eraser, okay. There we go. We're going to have to use opposite over adjacent for a given reference angle of 38. And we have to compare that in our actual triangle, the one that we're trying to solve, opposite over adjacent, 38. Because remember, the ratios have to be the same if our triangles are indeed similar, and they are. O over A is how we see the triangle. The calculator is going to see as tangent. The tangent of 38. Because remember, SOHCAHTOA. Okay, so we have the O over A ratio, so we're using tangent. In our real triangle, the one above, for a 38-degree reference, the adjacent side, the opposite side, excuse me, is 20, and the adjacent side is unknown. It shall be A. Okay, so if we're going to do some calculations, we need decimals. So 38, the tangent of 38 is going to be 0.7813, and that's going to be over 1. Is the same as 20 over A. So in this case, we're going to have to cross multiply and then divide both sides by 0.7813. So 20 divided by 0.7813 gives us an A value of approximately 25.598. And really quickly, we see the adjacent side is across or opposite of a larger angle than the opposite side, and so we do expect our adjacent side to be larger than 20, and it totally is. Okay, so for the hypotenuse, I actually prefer taking the trigonometric route. I think it's actually faster, so I'm going to do that. So the reference triangle is similar to the actual one. So if we're going to solve the hypotenuse, I was given the opposite side is 20, so opposite over hypotenuse shall be my ratio, using 38 degrees as a reference. So for the triangle that I have above, I should also use the same ratio. Over h, the calculator is sine, so this is really sine of 38. And then over h, well, O is 20, taking that from my actual triangle above. And the hypotenuse is what we're trying to find, so I'll keep that as an h variable. Okay, now to calculate, we need to find the decimalized sine value. So 38, the sine value is 0.6157 over 1, so we can cross multiply 20 divided by h. There we go. Okay, so again, I don't have space really to work out the next couple steps, but I mean, we've done a lot of cross multiplying, and so we cross multiply, and it looks like we're going to have to divide by 0.6157. 0.6157. All right, and so we get the h value of 32.483. And again, if we check, the hypotenuse value should be the largest, and it totally is, so that gives us confidence, gives me confidence that we're doing this correctly. All right, so for the perimeter, which is I can add on to the problem. We just have to add the three sides together. So we add 25.598, which we got for the A side, plus 32.483, which is a hypotenuse side, and then the given side of 20. Okay, and I get a perimeter of approximately 78.081. Cool, let's do another. So this was hopefully becoming very routine. So I have a reference angle here, 74. Okay, which means the side across from it is going to be my opposite side. Here I have my hypotenuse directly across from the right angle. Okay, and then I have my adjacent side touching my reference angle of 74. So it looks like we have to find the opposite side and also the hypotenuse. Okay, so let's do an opposite side first. Okay, we don't have a choice here but to use trigonometry. We only have one angle and one side of this right triangle. I want to find the OP. I was given the A, so that's going to be O over A for my reference angle of 74. And that should match my actual triangle over A, reference of 74. Over A, remember SOHCAHTOA? Okay, so using O over A, that's going to be tangent again. And in my actual triangle, well, I don't know my O value, so I'll keep that as like an OP, kind of like a variable. And then my A value is, what's that, 19? Awesome. Okay, let's convert to a decimal so we know what to actually calculate with. So tangent of 74, that ratio is 3.487 over 1, of course. Okay, so we have the OP over 19. It should be green, over 19, there we go. So cross multiply, so OP times 1 is equal to 19 times 0.3487. And we get an OP value of approximately 66.261. Okay, so now we need to find the, let's see, the hypotenuse side. Hypotenuse is this color. Uh-oh, board's cutting out a little bit. Okay, so I'm going to go the trig route. I know I could use Pythagorean theorem, but I actually prefer to set up trig ratios. I think that's a little bit faster. So I want to find hypotenuse. I was given adjacent. So adjacent over hypotenuse for 74 degrees as a reference. Okay, A over H is how we see the triangles. Your calculator is going to see it in this case as cosine. A over H is going to be cosine. In the actual triangle, A is known. That's going to be 19. The hypotenuse is not. We're going to find it, so I'll keep it as an H. All right, so let's find out what the decimal equivalent of 74 is for a cosine ratio. Looks like we have 0.2756 over 1, of course. So we can cross multiply with 19 over H. Okay, so on one cross we have 19 times 1. The other one we're going to have 0.2756 times H. And so solving for H, we get the H value of approximately 68.940. All right, and again, that fits. It's got to be the largest side of my triangle. The opposite side is 66. My hypotenuse is 68. I think we're golden. All right, perimeter time. So perimeter, let's add together. So I have 19 for my triangle already. 66.261 plus another 68.940. so my perimeter is approximately 154.201. Okay? And of course, if we had to round up or down, we could do that, but that's going to be our perimeter value, right? So this is part 2. There's 2 more of this type coming, but please again note, I'm breaking this up so you can kind of choose how many you think you need to see compared to the key, because they're all going to kind of be the same way. We had to find the missing side links in all cases using regular trigonometry. And then if I ask you to find the perimeter, it's just an issue adding some pieces together, right? So we'll come back in part 3 and we'll tackle these 2 triangles. Thank you.